The International Space Station has been providing us with groundbreaking science and discoveries for over 2 decades. When you think of humans as a spacefaring species, you may think of it as something limited to the future or science fiction. But in fact, for more than 20 years, humans have maintained a continuous presence in space via the space station. During that time, we have reaped the benefits of the research and science conducted on board. We have also managed to learn and develop engineering capabilities on the prime real estate outside.
Some of the really unique things we've been able to do on the ISS include things around robotics and autonomy, and especially with a new national capability, an initiative we have going on around on-orbit satellite servicing, assembly, and manufacturing. I would tell you that the ISS was really at the forefront of us starting this activity.
There is still so much left to learn and so much technology left to be tested in this incredibly unique place.
Really, the ISS as an orbiting lab provides the agency with the opportunity to test things in a microgravity environment. The main difference between terrestrial Earth testing and ISS is exactly that microgravity factor.
Using Station to practice capabilities and see how technologies will look and work in space is comparable to having a dress rehearsal before a big play. It provides us with the opportunity to learn, adapt, and tweak things as needed to drive down mission risk and increase the chance of success. This is especially important when you consider that many of these technologies and capabilities are things that have never been done before. Things like robotically refueling satellites in space that weren't designed to be refueled. NASA has big plans for sustainable exploration at the Moon, Mars, and beyond. First on the docket is Artemis, for which NASA plans to send the first woman and the next man to the Moon. In addition to testing technologies, Station also provides NASA with the blueprint for long-term human habitats in space. From learning about how human bodies adapt to a space environment in the long term, to discovering how to grow food and more, the orbiting lab provides invaluable lessons. As part of the Artemis program, Gateway will be an outpost orbiting the Moon, similar to the way Station orbits the Earth. Like Station, it will act as a destination for astronaut expeditions and science investigations. Unlike Station, it could serve as a port for deep space transportation, such as landers en route to the lunar surface or spacecraft embarking to destinations beyond the Moon. Gateway is a critical component of NASA's Artemis program and is possible thanks to strides made with Station.
So many technologies are required for us to sustain presence both lunar and then eventually when we go on to Mars. But with the Artemis program especially, and the lunar surface initiatives we're looking at now involve advanced power capabilities, advanced propulsion, advanced communications, trying to go to optical communications from radio frequency, entry, descent, and landing of large-scale mass. And again, the robotics and autonomy I'll keep going back to, those as well. But many different technological challenges, exist and are needed for us to be able to sustain those. What we're doing now will determine the future of what the agency's capabilities are.
The International Space Station offers endless possibilities in the future to continue to advance our identity as a spacefaring species.